All right, today is Thursday, March 25th, 2021. We're going to look over the molarity worksheet key. I want you guys to grab your work from yesterday. If you did not finish in class and you did it last night, it's fine. Get it out on your table. And I want you to check your answers to be sure that you did it correctly. And if you ran into a speed bump, let's look it over. Give me a moment to get your workout. Okay, you ready? Here we go. Number one, you simply add 2 moles of solute over liters of solution. That's the formula for molarity. Arshan, ladies. Number 2, 4.53 moles of lithium nitrate over 2.85 liters of the solution. You should have gotten 1.59 molar lithium nitrate, or just 1.59 molar is fine. Any questions? Okay. Number 3, 0.0073 moles of hydrochloric acid. I do not know why that L is capitalized. It should be lowercase. Divided by 2.39 times 10 to the negative second liters of solution. You should have gotten 0.156 molars, or molars, 0.156 molar. Questions? Okay, here we have 85.5 grams of sucrose. Convert that to moles and then do liters. You should get 0.250 molar. So it looks like you had to convert grams of sucrose into moles of sucrose and then just divide it by 1 liter and you get the molarity. Questions? Number 5. Looks like you just had to convert 214.2 grams of osmium fluoride into moles and divide it by 0.067 liters of solution to get 12.9 molar. That's very concentrated. 12.9 molar is, I mean, something that's 3 molar is very concentrated. 12, nearly 13 is really concentrated. Number 6. You should have gotten 12.3 molar potassium sulfate. Halfway through the worksheet. Any problems?
Can you go back to number 5, please?
Did you get the right formula for osmium fluoride?
I did, but I made a mistake. So
What mistake did you make?
I'll show you.
You don't have the right molar mass. You put OSF. It's OSF3. Osmium has a positive 3 charge. That's what the Roman numeral 3 means. So look up on the screen here. I know exactly what you did. So guys, the name of the substance is osmium-3 fluoride. When you see that osmium-3, what is the charge of that osmium? Positive 3. Whoa, that is way too big. So it has a positive 3 charge. And then it says fluoride right there. What's the charge of a fluoride ion? So how many fluorides would you need to balance out that osmium? So it's OSF 3. That's where your numbers were wrong. So there, this 214.2 grams, that's the amount given. This number here, that's the molar mass. That's what you would get from the periodic table. And so you just converted the mass to moles, and then you divide it by 0.0673. Any questions? All right. Let's go to 7. Someone who I saw being very resourceful yesterday was Tim. He took out his chem book, which is underneath your desk, and he said, I needed to look up a polyatomic ion. And he went to the back of the book, and he found it. Highly resourceful. Good job. If there was a polyatomic ion like chlorite, you guys were told you did not have to know chlorite. And that is not saying chloride. Chloride is Cl. Chlorite is ClO2. Okay? So if Tim, major props. Good job. He looked it up. You guys have a book underneath your desk. You did not have to know chlorite. That was not one of the 8 that I told you to memorize. So it is highly likely you had to look it up. Ammonium, you did have to know. NH4 with a positive 1 charge. Chlorite, ClO2, negative 1 charge. And then you get that compound. There's the molar mass. There's the amount given. There's the molarity. Just be resourceful. That's all it takes. Okay. Next one, you had to convert grams of magnesium oxalate into moles. But actually, you wanted to find the molarity. So remember this little diagram I showed you. Moles, liters, molarity. You want to know what is the molarity, blah, 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 blah. You had to convert the milliliters into liters. That's going to be 0.00365 liters. Convert the grams into moles. That should, is that right? Shouldn't that say molar?
Yes.
Okay. That's what I was getting a little confused on. All right. Yeah. No. You're actually going to learn that today or tomorrow about what happens when you go beyond the limits. There's really no limit. Okay, number 9. What mass of lithium phosphate would you, blah, blah, blah. You're given molarity. You're given liters. Okay, here's what you would do. Look at this pyramid. Cover up moles, and you do liters times molarity. That would give you moles. So liters times molarity equals moles. You then use the molar mass to convert the moles into grams. And so that's what they did here. And that's 115.79 grams. Actually, that's the molar mass, so you get 310 grams of lithium phosphate. This worksheet was not only an exercise on how to do molarity, it's also an exercise in something you guys learned in first semester, or you should know from first semester, how to put compounds together. Here's the case in point. Lithium is found in group 1. What is its charge? Positive 1. Phosphate is a polyatomic ion you had to memorize. Do you know what its charge is? Negative 3. So it should be Li3PO4. 1 phosphate, 3 lithiums. This worksheet was an example, or was a good exercise in how to actually get the correct ratios. So if you don't get the correct ratios, you're definitely not going to have the correct molar mass. Yeah.
At a certain molarity, would like the concentration be so high that the solute would be more than the solvent?
No. Number 10. Let's try to do this one. It says iron 2 nitrite. It says iron 2, so what's the charge of the iron? Now, nitrite is something you guys did have to know. It's NO2. What's the charge? So how many nitrates would it take to balance out that iron? So it should be Fe parentheses NO2 close parentheses 2. That's the formula. Your answer should be 130 grams. Okay. Someone asked me yesterday, what is the charge silver is always going to be? Silver is always going to be positive 1. So it says here, silver nitrate. Silver is always positive 1. nitrate is NO3, what is its charge? -1. So what ratio do they balance each other out? 1:1. AgNO3. That would be 3.4 grams. Is there enough nitrate? Looks like there is. You would have 0.6 left over. And then lastly, you have sodium hydroxide. What is the symbol for sodium? What is the charge of sodium? What is the formula for hydroxide? What is the charge of hydroxide? At what ratio do they balance out? 1:1. So again, I really like this worksheet because it makes you have to figure out the ratios. If you don't get the ratios right, you're going to get the molar mass wrong. Are there any questions with this entire worksheet other than the answers? Francis? Number 11. Okay, I can do that on the whiteboard. Juliana, is that what you wanted to? Okay. Remember, Carson came with me on this one yesterday. Did you figure it out, Carson? 11.
No, I got it wrong.
Let's see what we got here. A chemist has 4 grams of silver nitrate and needs to prepare 2 liters of a 0.010 molar solution. Will there be enough silver nitrate? If so, how much silver nitrate will be left over? All right. Let's see where to start. 2 liters of a 0. He has 4 grams. He's prepared. Okay, so here's what he has. 4 grams of silver nitrate. Here's what he needs. Will this be enough to make that? That's what you're trying to find. So let's do this first. Let's convert grams of silver nitrate into moles. We're going to have to do that eventually. So 4.0 grams of silver nitrate. I want you guys to get out your periodic tables and help me. What is the molar mass of silver nitrate? Well, let's look it up. Silver, it's Ag. It's 100, we're going to say 108 grams per mole. Nitrogen is 14 grams per mole. And I know that 3 oxygens is 48 grams per mole. So help me out. What is 108 plus 14 plus 48? 170? Okay, what is 4 divided by 170? For those of you that aren't even bothered to try, you're not doing yourself any favors. This is practice time. That's why your coaches make you practice every day. So by the time the game comes, you're ready to go. I'm hearing 2 different answers.
0.024.
So yeah,
Exactly.
0.024. Okay. So this is the amount a chemist has. This is what is available.
Could you keep that as grams? Because in the end, the answer is given in grams.
We could. We can go back and put in grams. So what we would have to do is get the moles and then convert that to grams too. All right. He needs to prepare 2 liters of a 0.010 molar solution. So use that little pyramid I made for you all. You have liters in molarity. I want to find moles. So liters times molarity. So what is 2 times 0.010 molar? What does that equal?
0.02 molar.
Okay. So this is how much he needs. So do the math. He needs 0.20 moles. He has 0.24 moles. Does he have enough?
Yes.
Okay. So there is enough silver nitrate available. But is Arshon saying, okay, the answer is in grams? Fine. So let's convert this back to grams. 0.020 moles AgNO3, 1 mole over, or excuse me, under 170 grams. What is 0.02 times 170? Yes, Juliana? What's up?
If it's a question like that and it doesn't specify the units of measure, should we?
Yeah, that's fine. No. But for the sake of showing that this is correct, I'm going through it. What is 0.02 times 170? 3.4. 3.4? Okay. That 3.4 grams is how much he would need. The 4.0 is how much he has. So up here, you take how, the question was, if he does have a much, how much would be left over? Again, guys, I want to remind you, this is how much he has. This is how much he needs. You do has minus needs. You see how much you have left over. That's in grams. Juliana says, do you have to specify? No. So, Juliana, you tell me. We already figured that he does have enough moles. How many moles would be left over? 0.004 moles. So if you said 0.004 moles left over, you would also be right. Now I just got a vibe that someone is saying, where did you get that from? This is how many moles are available. 0.024. This is how many moles we need. .024 minus 0.020 is like saying 24 minus 20. 24 minus 20 is 4, or in this case, 0.004. If you put your answer as, oh yeah, 0.004 moles left, that's fine. If you put 0.6 grams left over, that's also fine. Got it? What? Did you raise your hand?
No.
Oh. Oh, I saw your hand go up.
Oh, that was me.
Carson?
I was just gonna say, I actually did get it right. I didn't get it right. I thought I got it wrong, but I actually did.
Fantastic. Good news. Anybody else? Okay, make sure your name, date, period is on it. Either put the 24th or the 25th and turn it in.
Oh.
Okie dokie.
What? Did you do it?
What do you guys have going on tomorrow? Vocab quiz. All right. Let's see how much we're going to get to today. We're doing molality today. And solvation today. All right. Here we go. Today, we're going to start with diluting molar concentrations. And we did this a day or so ago. I told you if you want to dilute something, add more solvent. If you want to make something more concentrated, add more solute. It's really that simple, but there's a math equation for it. We call this M1 times V1 equals M2 times V2. There are 4 variables there, ladies and gentlemen. How many variables do you think that you will be provided on a given word problem? All you have to do is figure out where they go. You will be given 3 out of 4 every time. You just have to identify which one is which. Remember, the math and chemistry is easy. It's knowing which numbers to use that can be the hard part. So M1 and V1 represent molarity, which is M, and volume, which is V. Now, what do you think the volume is going to be measured in? What's the unit of measurement for volume? Liters of the stock solution. Stock solution is just the solution. Don't worry about the word stock. It's like what type you're using. And these are the initial values. So this is kind of like the before and after. Initial means initially, like what you started with, before. And then M2 and V2 are going to represent molarity and volume of the stock solution. And this is going to be your new values.
Are they inversely related?
Are they inversely? Yes. What, you mean like Boyle's law?
Well, just like it's a similar formula.
Yeah, it can be. Well, that's going to don't automatically jump to that assumption. Okay. Something to consider though before we get into this, and be sure you have your calculators out. After adding more solvent, the ratio of solute to solvent particles has decreased. That means that you're making it more diluted. Okay, so I'm going to give you guys a practice problem. These are going to be like your little keys to the kingdom. It's going to be a tutorial, a cheat sheet, if you will, on how to solve this problem. We'll go over it step by step. I do want to see if you can do it on your own first. Then I'm going to break it down step by step. So this is example problem 13.3. This is your third example for unit 13. Here we go. If you know the concentration and volume you want to prepare, you can calculate the volume of the stock solution you will need. What volume in milliliters of 2.00 molar calcium chloride. Here's another example of the first semester. What is the charge of a calcium ion? +2. What is the charge of a chloride ion? -1. At what ratio will they balance each other out? 1 to 2. Hold on. Yeah. Okay. I'm going to just close my mouth and let you guys give it a shot, and then we'll break it down step by step. Mm-hmm. All right. So with a problem like this, you are given 3 variables. You just have to solve for the 4th. That's all. That's all it takes. So, max. We have variables v1. Actually, let me start over. m1, v1, m2, v2. Can you tell me tell me just one variable that you can identify? Tell me where it would go. Is? Correct. Kendall, tell me another. 0.50 what? Good. Jade, tell me the third and final variable that we're providing. Mm-hmm. Which means we are not given volume. It is going to be in liters, but it does specify that it wants you to convert it to milliliters when you're all done. Don't forget those little parts. Okay. So before you even plug in any numbers, just do M1 times V1 equals M2 times V2. You guys need to isolate V1. So use your old school algebra 1 skills. Derek, what would we do to isolate V1? Divide M1 on both sides. So your new equation is V1 equals M2 times V2 over M1. Let's plug in your numbers. M2 is 0.50 liters. I got that crisscrossed. 0.300 molar times 0.50 liters over 200 molar. Molarity cancels out. 0.3 times 0.5, what is that? 0.150? My calculator's way over there. Somebody tell me? Just make sure. Yeah, 0.150. And what is 0.150 divided by 2? Okay. Your answer should be 0.075 liters. Now, are we done? No. How many milliliters are there in a liter? So shift the decimal 3 places. 1, 2, 3. To the right, you should have 75 milliliters. Yes.
Before I even like salted milliliters per milliliters, not
No, because you're, well, hold on. Did you convert the 0.5 liters into milliliters? Okay, then did you? Yeah, then that's fine. Yes. Any questions, guys? All right. It's very similar to Boyle's law, where they're multiplied and you're given 3 variables. You just have to find the one you're missing. All right. Let's move on to the next topic. Molality. And the symbol for molality is the lowercase italicized m. We can't do a regular m because that's used for milli and it's used for meter. Now, just like Jade, you had trouble with this a moment ago. If I give you 0.5 big M, how would you say that? 0.5 molar. Do you know what you would say if it was like this? Anybody want to give it a shot? Pretty much. Molol. Sounds weird. Say it 5 times fast. Molol, 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 molol. Hey, Nick, say toy boat 5 times fast.
What?
Toy boat. Bet. Toy boat. Can't do it. All right. Here we go. For molality, the volume of a solution changes with temp as it expands or contracts. So the volume is going to change. If it expands, it gets bigger. If it contracts, it gets smaller. This change in volume does affect the molarity. So molarity is moles over liters, but if you're changing the volume, the liters, you're going to change the molarity. If the molarity, if the liters in the molarity goes up or down, that will affect the molarity in the entire solution. However, masses do not change with temp, thankfully. This is known as molality. This is the unit of measurement that we use. Molality is the ratio of the number of moles of solute dissolved in kilograms of solvent. So there is your equation. So there's your vocab term. And here's what it's dividing. Moles of solutes over kilograms of solvent. And as Francis so eloquently said, molal. Yeah, molal, molol, whatever you want to place the emphasis on. It's all the same. Okay, well, given that formula, let's do our fourth practice problem. Here we go. What is the charge of sodium? What is the charge of chloride? At what ratio will sodium and chloride bond together? Correct. Okay, everybody. See what you've got. I'll give you about 3 minutes on this one. Okay. You need to get moles of solute over kilograms of solvent. Let's see. Eeny, meeny, miny, Kevin. What is the solute in this problem? Is it water or is it sodium chloride? It is sodium chloride. And how many grams of it are we provided? That's right, 4.5 grams. What do we need to get it in terms of? We need to get in terms of moles of solutes. Moles. So for this one, everybody, step one, convert grams of NaCl, which is your solute, to moles. Miss Jade, how do we convert grams of something into moles of something? Molar mass. So you need to refer to your periodic table and find the molar mass. What is 35.5 plus 23, 58.5. 4.5 grams of sodium chloride. $58.5 grams, 1 mole, .5 divided by 58.5 equals 0.08 moles. Okay, check. We have it in moles now. Fantastic. David, our solvent is water. We have 100 grams of it, but what do we have to get in terms of?
Kilograms.
We have to get in terms of kilograms. So number 2, convert grams of water, which is our solvent, to kilograms. Well, this one should be pretty easy. David, how many grams are there in a kilogram?
1,000.
1,000. So we put 1,000 grams on the bottom, and we put 1 kilogram on top. They're the same thing. You just have to make sure you put them in the right spot. Grams of water cancels out. So 100 divided by 1,000 is going to be 0.100 kilograms of H2O. All right, we have that. Now you just have to set up molality. Molality is moles of solute over kilograms of solvent. So 0.08 moles over 0.100 kilograms. That should equal 0.8. Francis, you want to say it? Sure. Molal. Sounds weird, but that's correct. Now, I will tell you all this. If Francis puts 0.8, she has that little italicized M, and Jade were to put 0.8 moles per kilogram, is there any difference in their answer, really? No. Those would both be acceptable answers. Unless the problem specifically says, write your answer in terms of molality. Then I would not be able to accept that. But that's basically the same thing. If Max, for instance, Max and Kendall were doing a molarity problem, and the correct answer is 0.5 molar, and this is what Max put, that's the correct answer, he's right. If Kendall puts 0.5 moles per liter, that's the same thing. And so that would be right too.
If it's the same thing, why can't you accept it? If it's not-
If the problem specifically says, write your answer in terms of molality, it just wants you to do it. All right, how much time we have left? We have 5 minutes. We can fit this last one in. Mole fraction, everybody. Mole fraction is pretty simple. I mean, really, it is pretty simple here. This is just about the ratio of the number of moles of solute or solvent. I'm going to do, if you wanted to find, let's see, let's say the solute is XA, the solvent is XB. And let me put a solute fraction, solvent fraction. You would do NA divided by NA plus NB. And this would be NB divided by NA plus NB. Now, I hate the way that looks because if I were a student, I would be scared. Oh, God, he's giving us more variables. I don't know what they stand for. I feel your pain. So let me put it to you like this. Forget all that. I'm getting rid of it. Everybody look up here. Nick, how much do you weigh?
155.
David, how much do you weigh?
145.
I want to know how much they weigh together. Okay, easy. 300. 300 pounds even. Nice round number. I want to know what fraction David is of the whole. So David is going to represent he's going to be, let's say, XA. And Nick, his fraction, whoa, what happened? Is going to be XB. So what do I do? Francis?
Move up a little bit so it's not,
I don't want you. I got rid of that for a reason. That's scary.
Write it down?
Not yet. No.
Okay.
What would you do if I want to find out like what percent or what fraction Nick or David is of the two of them combined? Arshawn?
1, and then the 2 of them, 1 over the 2 of them.
So I would do David divided by the total to get David's fraction, and I would do Nick divided by the total to get Nick's fraction. So for David, we would do 145 divided by 300 is 0.48. For Nick, we would do 155 divided by 300, which is 0.52. That's basically it when it comes to mole fraction. So let me put it in terms of chemistry now. Let's say that we have 36 grams of hydrochloric acid and 64 grams of water. What do you think your solute is and what your solvent is? That's your solute. This is your solvent. Now, you can probably do the mental math here. What's the total number of grams here? This is going to be 100 grams total. But here's the problem. It's a little problem. It's not that big of a problem. This is called mole fraction, not mass fraction. So what are you going to have to do with these values? We're going to convert them to moles. So here's what I'm going to do. We have 1 minute left. Converting to moles just takes time. Then you just add the moles together and divide. We'll do this first thing tomorrow where we pick up where we left off, and then we'll get into the next section.